For question 4 regarding glycolysis, what is overall happening in the 3 parts or phases of glycolysis is, in the first phase, the priming energy investment phase, we are forming glucose 6-phosphate utilizing 2 ATP molecules. So we're investing ATP now to get the process going to produce ATP in the end. This phase occurs in step 1 of glycolysis when glucose is phosphorylated or given a phosphate molecule from ATP using the enzyme hexokinase to produce glucose 6-phosphate. In the second phase of glycolysis, which is the splitting phase, we are splitting a 6-carbon molecule into 2 3-carbon molecules. And this occurs in step 4 of glycolysis, where fructose 1,6-biphosphate is split into 2 3-carbon molecules by aldolase. And this forms DHAP and glyceraldehyde 3-phosphate. Now, in the third phase of glycolysis, which is the oxidizing, reducing, or energy generating phase, we are forming 4 ATP molecules, and we're also oxidizing and reducing molecules. So these occur in step 6 and 10 of glycolysis. So in step 6, we are taking glyceraldehyde 3-phosphate, oxidizing it, so we're taking its hydrogens, and phosphorylating it, so we are giving it a phosphate, by the enzyme glyceraldehyde 3-phosphate dehydrogenase, and we utilize an NAD molecule because we take those hydrogens that we took from the substrate and we reduce NADH or give those hydrogens to NAD to form NADH plus H, and we form 2 NADH plus H molecules from glycolysis, so that is where they're produced. And then in step 10 is where we get our ATP. We take phospho NO pyruvate. We transfer a phosphate from that molecule, from that substrate, to ADP to form 4 ATP molecules, in addition to 2 pyruvate molecules through the enzyme pyruvate kinase. And with glycolysis, we form 4 ATP, invest 2, so we come out with a net of 2 ATP. Now, 3 types of enzymes that are used within glycolysis and their action is we have transferases, which, for example, are kinases, and they move an element, usually a phosphate, from one substrate to another. That's seen in step 1 of glycolysis that I mentioned. We have a lot of isomerases, specifically a mutase in glycolysis, and this rearranges parts of a molecule to form a new one. So we take a substrate, rearrange it, and produce a different product. And then we have oxidoreductases or dehydrogenases are examples, and these enzymes are used to catalyze or make a reaction go, and then they are for oxidation or reduction reactions. Now, 3 of the most influential enzymes in glycolysis regulation, the first is hexokinase, and the molecule that goes with this enzyme is G6P. When we have an increase of G6P, this inhibits glycolysis because we exercise, we break down ATP, we have G6P, and there's no accumulation of it because we're continuously going through the glycolysis and utilizing it. So then when we stop exercise, we now have an accumulation of G6P. So that tells glycolysis and hexokinase to chill out, stop, overall inhibiting glycolysis, so we stop utilizing our G6P to make ATP that we don't need right now. The second most influential enzyme is PFK, or phosphofructase kinase, and a molecule that plays a role with this enzyme is phosphates. When we have an increase in phosphate molecules, this enhances glycolysis in PFK because, again, we're exercising, we're breaking down ATP and PCR, and so that leads to an increase in phosphate molecules. And since there's an increase in phosphate molecules, this means that we can utilize these free-floating phosphates to resynthesize more ATP. So that tells glycolysis and PFK to keep going, keep utilizing the phosphates and producing and resynthesizing ATP. And the final enzyme is pyruvate kinase, and 2 molecules concentrations that play a role is when there's an increase in ATP and an increase in PCR. This inhibits glycolysis because, again, we exercise, we break down ATP PCR, that tells glycolysis to go, but then when we stop exercising and now we have an increase in ATP and PCR, that tells glycolysis and pyruvate kinase to chill out, stop, because we don't want to accumulate those molecules and continue to use them. We want to be able to save the resources needed to resynthesize both of those so that when we are exercising, we can continuously keep going, and accumulation tells us that we don't need to make any more.